Good evening. My name is Wahid Lutfi. Welcome to my Web University free educational videos. In today's session, I'm going to be discussing what is operating system. So without further ado, let's get started. I'm going to do a slideshow here. So as you can see on the screen, what is an operating system? And whether you used Mac operating system, Linux operating system, or Windows, or Android on the phone, you have been interacting with operating system all along. And you might be just working with the DOS version of disk operating system, or Windows 3.1, or Windows NT, or Windows 7, Windows 8, Windows 10, and so on. And then you might have also done with a Linux environment, like Linux Red Hat, or Linux Ubuntu, OpenSUSE, all those other ones, as well as Unix operating system. Unix operating system like Mac OS X, which is a Darwin BSD version, or Solaris, which is Oracle Sun Solaris. It used to be called Sun Microsystem, Sun Solaris, or Open Solaris, or Solaris Express. And those are some of the names for the Solaris platform, but they're also based on BSD. Or you might have worked on the mainframe operating systems, or IBM AIX version, or DEC OSF1. But doesn't matter what version you worked, you interacted with an operating system. So here we are going to discuss first what types of operating system is available out there. As you can see, I'm listing about 5 of them. One of them is batch processing, batch operating system, which is submitting jobs. I'm going to discuss each one of them on subsequent kind of pages. So let's just go with batch operating system at this time. The next one is time sharing, which is CPU and resource are in a slice. Distributed operating system, which are multiple nodes or computation operating systems, or working on independent of each other, but they are all together as a collection. Does the distributed operating system, similar to distributed databases for database management system. Real-time operating system are very critical to the time, so they guarantee the operating system to be performing some work at a particular time. Network operating system is NOS, which is all kind of operating system that you have used, Windows, Mac, Linux, Unix, and they are providing some sort of NOS, or network operating system, over the LAN, local area network. So let's go to the first one, batch operating system. What is a batch operating system? So in a batch operating system, you have a computer on the right side, and then now you have an operator, and then the users are not directly interacting with the computer on the right. So the user submit the jobs, job 1 through 4. In this case, 4 users are submitting their jobs, and then the operator takes those jobs, then put them, categorize them into batch, and that at some point he or she submits it. In this case is a she submits the job at to the computer, and then the job is going to run as a batch on off hours, or maybe even at a certain time of the day, and that the operator decides what jobs or what batch scripts should be executed at what time of the day. So it is the job of the operator to categorize them properly and submit them to the computer. The computer actually, whether it's a file server, or a database server, or an NFS server, anything that is submitted based on the job, batch job, it just does the work on the server side, then it returns the result to the user, in this case operator, and the operator gave the report to the users. Time sharing operating systems, on the other hand, is that every user that are on the system, they don't run all the time to get all the resources that is available on the system, but it's a time slicing, which is mostly like about 10 to 100 milliseconds of computer clock. So as you can see here on this example that I draw a nice graph for you, basically the CPU, central processing unit, is in the center of this graph. And then the CPU takes the job that is coming to the user and the program, multi-programming, multi-users that are submitting at the same time. They are not going to be running all concurrently. Even though it is running in a nanosecond or 10 to 100 milliseconds instruction, it seems transparent to the users as if they are concurrently running their programs. So when they submit it, only one process here, in this case is user 5, is in active state. So the running process could be an either active state, which means it gets CPU cycle, then the job gets submitted to the CPU, and then CPU reads the data from memory and then fetch it into arithmetic logic unit or the gates and everything, or the registers, and then calculate it and then return the value. Similarly, if there's any disk I/O activity that's happening between memory and CPU and the disk, it was swap and swap out, all those activities are happening within these resources. So the running process that is active, it's only that one is a time slice that this user 5 is active state. At that time, only user 5 can run on the CPU. Everybody else has to either be in ready state or wait state. In this case, user 5 is an active state, and user 6, as you can see, I draw the circle in between the bigger circle, and user 5, I draw the circle of the CPU slice time in the middle of this graph. So that means that user 5 is already in the system in active state. It's in running state. Then the user 6 is in R state, which is ready state. When you run the Linux command, for example, or some a Unix command top, you could see these process or in running state or a ready state or wait state. So the running state is the active process, and then the ready state is the next process that when this time slice of user 5 goes away, user 6 takes over, and then that process takes CPU cycle. Similarly, and then the user 1, 2, 3, 4, they're all in wait state. So they are in wait state, and then as a result, they're just basically happening with wait state to wait on the system. And then as user 6 gets into active state, the next user gets into ready state. So this is normally in a round robin circle. So everybody gets their fair share slice in system. And this slicing is sometimes called time slice, sometimes called time slot, or quantum, or it is usually in the order of 10 to 100 milliseconds of computer clock. Distributed operating system. Distributed operating systems, or each of them are a separate independent operating system that are running, and they're connected throughout the network with the independent software that are all combined together, work as a collection of operating system. We call it the distributed operating system. And then the term distributed operating system is used for database as well, because sometimes you are running multiple databases on multiple nodes or computation nodes that does some work, but then as a collection, they just have to make sure the transaction is atomic. So the replica of the database is updated as well as similarly on the operating system. There's another term called DDoS. DOS, as you know, on Windows is a disk operating system, but in terms of security, DOS is denial of service. Denial of service is sometimes when the requests are coming to in security. I'm talking right now. So the denial of service is when somebody is submitting a request, and then as a result, and they are just overwhelming the server or the process that is running as daemon to just handle the request. So they overwhelm it with more requests, and then it is going to be just not available to provide the service to other users. So for example, imagine if a line of somebody is just working as a main person, and everybody makes requests to that person, then he can handle so much. After a while, he can start. But on terms of operating system and computer programming, the software doesn't get tired yet. They can get overwhelmed by I/O, input output. The buffer gets full, or the amount of requests that comes in, the amount of time that is supposed to be handled. So a distributed denial of service attack is DDoS. Distributed denial of service is DDoS, which is a distributed denial of service. In the case of sometimes you could say, well, there were times back in maybe 20 years ago or some years ago that Yahoo website was under the attack of distributed denial of service, which means that at that time they made so many requests to the Yahoo web server that the Yahoo web server was just kind of hanging to just serve the community. And then that is just usually done by those hackers, that they did it through multiple servers, multiple clients that maybe in thousands, and that they are submitting requests and that in millions, and that it goes to the same bandwidth, to the same network of Yahoo or Google or Amazon or anything, and they are just doing it. But now the web servers and the software that is running on Google and Amazon and web server is much smarter. It's much kind of efficient, and they just are going to deny some of those requests if it is 400 or more than 100 requests coming from same IP address or same subnet at some nanosecond, then they automatically know that this is a DDoS attack. So that is a solution to the problem. But here we're talking about distributed operating system, and some example of distributed operating system is IBM AIX, which is on the distributed operating system. Oracle Sun Solaris, for example, it provides a distributed operating system. You can have multiple Sun Solaris machine on different servers and workstation. They all work concurrently within the same software. For example, let's say the file system is Andrew file system. I used Andrew file system, which is built at Carnegie Mellon, University of Carnegie Mellon. Originally, Andrew file system, it allows you the file system to be distributed. So you can run multiple clients as workstation and servers to just read the same storage, same data. Similarly, for this was also, we took a class when I did my master's degree as a computer science major. For my master's degree, I had to take one distributed operating system class and one distributed operating system and one distributed database class. So you do take this kind of small project like Andrew file system, or how to replicate the database on multiple instance of different nodes. So let's talk about the Windows distributed file system. That is also like in TFS and other ones. Sometimes you do have that option of doing distributed file system sharing. Network file system, NFS, is also built by Sun Microsystem a long time ago, and then it is very great for kind of NFS file sharing and allowing through mount points between Linux and Solaris and Windows to do it. Similarly, but server message block, Samba. Samba is another protocol that allows Linux and Windows and Unix machine to just read the data. So between Windows and Linux and Windows and Unix, you can just have a storage and then shared between them. Ceph is another one, is Common Internet File System that is on Windows that allows file sharing. Google file system, as GFS is similar, allow you in distributed file system. So real-time operating system, what is the real-time? The real-time operating system guarantees the critical task to be completed within a range of time. So some of the example of real-time operating systems are airline traffic control system, command control system, airline reservation system, heart pacemaker for patients that have their pacemaker on their heart, network multimedia system, robots. As you can see from these examples, they're very critical to be executed at a certain time. That's why a real-time operating system has two key features, which are predictability and determinism. So it has to be predictable that it is guaranteed and determined that it's going to use the same core single processor or multi-core processor and execute these programs concurrently, switching tasks rapidly between the task and giving the impression as if multi-users or just working on the system, multi cores or serving the system concurrently, and there's no kind of like slowness or anything. Network operating system, which is the last one in this list, it is NOS, which allows you to basically use a system that are special function for connecting computers and other devices. All the devices that are on the LAN, whether it's computer or hub or other gateway or routers, all of them, they are connected to this LAN, and that LAN is controlled by the NOS, the network operating system. In the case of examples, if you look at some of the examples here, Microsoft Windows Server, for example, does network, operating systems. Unix, AIX, for example, OSF1 and DSE, OSF1, Oracle Sun Solaris, or Sun Microsystem Solaris. And Sun Solaris, they had it on Spark architecture as well as x86, and Oracle also have Oracle OVM that does all of this on the Linux side as well. Mac OS X, Darwin, and BSD. As you know, both Solaris and Mac OS X is based on Berkeley software distribution. The operating system is very safe, very secure, and Sun OS and Darwin are both BSD based. And FreeBSD is also BSD based, and then it's a free to the community. That's why it's called BSD. Originally, Berkeley Software Distribution wrote the BSD version, which is very secure, very nice operating system. We used it a lot. And then now you are using it on Mac OS X as Darwin. It's called BSD and Darwin version. And then also for Sun Solaris, it's BSD Sun OS. Current version of Oracle Sun Solaris is 11.4. I have a lot of videos on all of these platforms, including the Linux Red Hat, for example, Linux Debian, Ubuntu, Linux Fedora, Linux OpenSUSE, Linux CentOS, and Linux Rocky. All of those ones are Linux Mint. All of those are very great example of a network operating system that support NOS on the LAN. So what are some of the features of operating system? Let's slow down here. We're going to just discuss new topic, which are the feature of operating system. So, and some of the features, for example, it provides the platform for running applications. Basically, an operating system, it gives you the environment or the platform to run your application smoothly and securely, maybe making sure it's safe. Resource management, all the hardware that you have, it has to manage it properly. So the operating system has memory manager, CPU scheduler, process management, I/O. Process management, this could be system daemons, could be application and user processes. And then I/O management, which is internal disk drives and external storage, input and output, all the I/O that are happening, whether it's physical storage or virtual storage, virtual disk data that are read on memory, and they are all managed by the operating system. And also provide a file system abstraction. The file system abstraction is basically created through makefs and creating through files. The file system on the operating system, when it creates it, then it creates like inode or FAT for Windows, which is FAT file allocation table, or in TFS, network file tables, or in case of Linux and Unix, inode. The structure has information. So basically in an operating system, everything is considered as a file, whether it's a device, whether it's a file, whether it's a directory, whether there's anything that you can name it, it is stored as file. And block file, control files, and then devices and or files, printers or files, and then basically USBs or files, everything. You're having a file handle. Based on that file handle, you're writing and reading I/O from it. And then there's a lot of different type of input and output that are happening on the system using those file handle. So let's talk about the provide network support. So the network support, operating system has to provide network for basically client-server architecture, cloud computing, distributed networking, distributed operating system, and distributed databases. And that's essential for a system to be working. A system that doesn't have network is not working. That's how you easily could memorize that one. If you don't have network, you are not working. And then even with finding jobs and having in real life situations, sometimes it's better to be networking with the right people. Otherwise, if you are not connected with the right people, it doesn't matter how much knowledge or how much information you know, you might not be easily getting the same kind of jobs that other people could get it, just because they have the same connection, unfortunately. And so provide system and application security features. So what are the provide system application security features? Every operating system has to have security features, like, for example, firewalls. So whether you're running a Windows operating system, Linux, or Solaris, there's either IP tables or IPF or some sort of system D firewalls, or Windows firewall, or even through the border routers, you have firewalls that you're configuring it through routers and everything. There's a lot of different type of firewalls and security software. Security software sometimes could be like secure shell daemons, SSH client, and secure FTP, secure copy, scopy, and all those things are allowing you to just make sure that you have security software. Encryptions, like, for example, SSL certificate, server certificates aside, and TLS, everything that are there based on those security features, encryption, and then Huffman coding. And so there's so many of them, and that there's different things for different purposes. So provide user interface. It also provide you a GUI, graphical user interface. So both Windows and Linux and Unix, everything now you are using it, even on Android, the laptops and desktop, and then also on the cell phones, everything portable. Even on browser, you have some sort of GUI, graphical user interface. So, and the graphical user interface are icons and buttons that you can easily manipulate and click on it and then just do it. In addition to that one, sometimes, and depending on whether you're using Windows or Linux, on Windows and Linux, you have different interfaces for command line argument. For example, Unix and Linux provide shells that are Bourne shell, Corn shell, C shell, True C shell, ZSH, and everything that you are allowed to run command line syntax at the terminal, and then even write a shell script to just manipulate that data and then just get some output. So the shell is the interface to basically between the user and then the actual operating system, which is the kernel and that is underlying daemons. So the command line is the like Windows has command line interface that you can run with a CMD. We call it command line interface, that you can run any command line interface. Obviously, whatever is on command line and shells usually is also on the GUI, and then vice versa. But if you have the command line development skills, you can write your own customized scripts as well, to that whatever is not in the GUI, you can write automation for your system. So that's another advantage of the operating system having some utilities and system services. GNU utilities, for example, on the Linux side, and Windows, anything that is not coming with Windows, let's say for zip to do a utility like zip interface to just compress things. But on tar and ganzip and everything else is on Linux and Solaris, they're already provided. But if the software is not there, then you can just get it from GNU.org or RPM, Red Hat Package Manager, or the Ubuntu repository or something, or Fedora repository. You can just download them and install them. There's certain package managers for every operating system that you use, whether it's Linux, Windows, Mac. They have their own package manager, which my other classes or videos talk about those ones in details. So support application development, compilers, interpreters, and database. Yeah, for all the operating system that we have used, and there's some sort of compilers. If it's on Windows, maybe it is Windows x86 based compilers and interpreters and database software. And if it is Linux, it's x64 and then x64 and x86 based architecture, as well as maybe if it's Solaris Spark architecture. Doesn't matter what it is the compilers and the interpreter will just work on those platforms, and it's portable, and then you just have to download them and use them. Some of the compiler examples of GCC, GNU C collection compiler, for example, or Bolan C, or Visual Studio Code on Windows and Linux. Also, you can get that on Mac, and then Xcode on Mac, and so on. Interpreter like Python interpreter, PyCharm is the IDE version of it that is available. And then the database could be like MySQL, Oracle, Informix, Sybase. There's a lot of different SQL Server, Microsoft Access, and so on. All of those are example of database. On subsequent classes, I'll have those ones in detail, what's going on with them. And now I'm going to discuss what is a kernel. A kernel is the core part of the operating system. That means every operating system, whatever is the main part of the operating system is, and that is called kernel. It's like almost central processing unit on a computer. Is the core part of the operating system. So it has device drivers and it has interfaces to work with the users, and on behalf of the user, it makes requests to the hardware, read and write from the hard disk and memory and CPU and everything else, and then manage it and make sure that the user has the proper permissions to read and write to those files and directory that the user is requesting. And then if the user doesn't have the privilege, and then it requires higher privilege like root access or administrator of access. And if that is available for the given user, then the kernel does the work to just do all the read and write, and based on that one works on it. The kernel is also as objective is between the communication between the user and the applications and all the hardware that are underlying running those applications. So the kernel is responsible for booting the operating system efficiently. In this case, I'm discussing a multi-user, which is Linux and Solaris and Mac, not the DOS disk operating system. Even Windows is a multi-user, starting Windows 95 with TCP/IP packages, everything is a multi-user. So multitasking is running multiple tasks at the same time. And multi-threading is the environment that within one given task, you can run a smaller threads, smaller functions to just execute faster. Basically, parallel processing is also another concept that operating system provides, and the kernel is responsible for managing all the resources, hardware, user requests, and all the availability of those ones, and basically is the core part of the operating system that interacts with between the hardware and the user and then the applications. So let's go for a second and discuss some of the examples of the operating system that you might be aware of it already, and some of them that maybe we discussed. On the left side, I'm showing the Unix AT&T version of Unix, which was built around 1969 at Bell Laboratory by Ken Thompson and Dennis Ritchie. God bless Dennis Ritchie. He was the C programmer, very pioneer of it. He wrote the Unix operating system with Ken Thompson. Ken Thompson is, thank God, is still alive. He is working on a lot of utilities and a lot of GNU stuff, and he also wrote like a part of the Go language. So he does still contribute a lot of it, and then he's a co-founder of Go language. So when Unix AT&T version was come out at Bell Laboratory in 1969, that's the epoch calendar. 1970 start the Unix calendar on January 1st of 1970. It's called the epoch calendar. In this case, Berkeley Software Distribution later on introduced the BSD version of Unix, which is Sun Microsystem, Sun OS, and also Mac OS X, Darwin. They are borrowed a BSD version from Berkeley Software Distribution. They built their version of Unix. And then there's another version of BSD called FreeBSD. That's by open source community. And then the Sun Solaris Sun Microsystem, when Sun Microsystem was acquired by Oracle, Oracle has been maintaining Sun Solaris. The latest version is Oracle Solaris 11. It is both on Spark architecture as well as x86. I have used that one. I'm certified for Oracle Solaris since 2003, and I have a lot of knowledge about Oracle Solaris. I really love the platform and worked on it, and as well as a Linux platform. I've worked extensively on all of these ones for many years, at least 20, 30 years on some of them. So the Oracle Solaris also, they have Oracle OVM, which is Oracle virtual machine for that's running Linux and x86 version of Solaris, and then Red Hat Linux also on the OVM. So then on the right side here, you see the GNU Linux. GNU stands for GNU is not Unix, it's like recursive. But basically what it is saying that GNU is not Unix and GNU is not Linux. Basically, when it says GNU is not Unix, GNU is recursive, it's referring to saying that we don't provide the operating system. We provide a set of utility. The Linus Torvalds for example, put the GNU and then the kernel together, and then now Red Hat version is running, or a Linux version is running all together, and they combine it, and then now people have their own version of Linux, which is Red Hat, OpenSUSE, Ubuntu. Ubuntu is also having all the GNU utilities, as well as the GNU, the Linux Debian distribution. And then similarly with Rocky version is for Red Hat that replaced the CentOS version, and so on. Red Hat is still at version 9 currently, and then the 10 is coming up, I believe. So Windows, on the other hand, on the right side, is a very great operating system. All of these operating systems nowadays, they have graphical user interface as well as command line. Some people, they still joke around, say, well, Windows is user friendly, but Unix and Linux is not. And my joke back is that no, they are both they're all user friendly. They all chose their friends. You have to learn them, and then in fact, if you learn Linux or Unix or Solaris, then they choose their best friend based on how much you know them, how much you learn them. And so whether it is Mac or Windows or Linux, they all are user friendly. And then they all choose their friends, their best friends. So let's go back to the Windows. Windows, as you know, it started from DOS, and then Windows 3.1, 3.11, Windows NT, Windows 7, Windows Vista, and 8, and then there was no version 9, then they jump into 10 and 11, now 12. So it is just getting better and better, and you just don't, I never complain about which one is better or what is the feature that I like the most. I just use them all, and then whatever I just don't have a feature for it, I just try to use a different application or operating system that has it. And if I can just automate it to see that if the system, for example, one of the example people say, well, Windows, for Windows 12 or 11, you have to buy a new hardware. And then for that purpose, sometimes your hands are tied if you cannot buy new hardware for every time you a new OS comes in. In that case, what I could do is just run the old hardware with Linux, Ubuntu, for example, or Red Hat, or Rocky, or Solaris x86, something. As long as I can just get the same kind of application and development tools that I'm interested, I learn it, then that's good, sufficient enough for me. So no complaint from my side. I also, from this one, I was talking to you about the Linux and other ones. Since I made about more than 350 videos already on the internet for the community, for students and people to enhance their careers or learn it for their school purposes, because I taught a lot of classes at the university level and University of National University, Cal State Fullerton, Computer Learning Center, Pasadena City College. I have taught it at least 7 years of part-time teaching, or 8 years of part-time teaching at different level of courses, whether it's operating system, database, compiler classes, C, Pascal, Ada, Fortran. Some of those ones I did not teach, Ada, Fortran, Pascal. I took it myself, but classes like, for example, Oracle, or MySQL, or C, or Visual Basic, Windows NT, operating system, and then Python, C, C++, and then Bash scripting. I taught all of those classes a number of times, compiler classes. So just bear with me. I'm going to just show you this book that I wrote. It's called The Direct Path to Linux Ubuntu, which is available on my website called mywebuniversity.com. And then this is about 7 chapters, and each chapters I teach you how to learn Linux operating system. The first chapter discusses about a pioneer of the Unix operating system. Then it's Richie and Ken Thompson, and all those details are there. The second chapter is the basic of Unix and Linux operating system. And then third chapter is intermediate level of Linux operating system. Fourth chapter is advanced Unix operating system. And the fifth chapter is the shell programming. Sixth chapter is the Linux web server. And then the seventh chapter is my Python program that I wrote that it basically allows you to dynamically get any of the 13,000 or whatever Linux command that are there. You can get them online available for you. So I hope you enjoyed this session. I'm going to just go to the next one, which is thanking you for watching this video. I really appreciate your time and to show your support so that I can better serve you and provide the best training and meet your needs and expectation. Please do one or all of the following. So whether you do one of them or multiple of them, it's up to you. Please watch and learn from my Web University for Education videos on the YouTube channel. Please make sure you make appropriate comments or suggestion so I could better help you based on your needs. Whatever you need, you let me know. I will just make a video for you. Please visit mywebuniversity.com for more technical documentation, because I have about more than 66,000 technical documentation on Mac, Solaris, Linux, PowerShell, and then Windows help, as well as additional books and videos and training. And then this book that I just showed you is entirely available online. You don't need a VirtualBox, you don't need a Docker, you don't need anything. You just need a browser and internet access. Go to my website and start learning. And then if you are just not interested in practicing online sessions, you can just watch the videos at youtube.com/@mywebuniversity. This is the handle that you can find me at YouTube. Please don't forget to subscribe at our channel, and then that way we could just notify you with the latest as soon as it comes in. So this is the actual channel. If you are interested, you could go and watch it and these videos, and at the end you could subscribe, or just click on the link and that I just showed you, and then just subscribe there. Also, you can go and visit mywebuniversity.com, where is my main page, and I'm putting all these videos as I post them on YouTube, as well as sometimes it gets updated. So this is the book that I was telling you that is all online. So you don't need internet. I'm sorry, you don't need Linux or Unix installed. It's all on my cloud computing environment, and then all you have to do is just follow these pages. And there, for example, if you go to chapter 2 for the Linux Ubuntu stuff, you can just see the basic Linux command and all these videos that I have already for these commands there. So if you just say, okay, what does the cat command do? The cat command here, I'm showing you examples that you can click on it and you will get the output here. And the output here, as well as if you want to just see the manual pages for it, just click on cat, and then you will get to my other chapter 7 book, which is chapter 7, which is on the Unix manual pages. You can just read the manual pages here. Here, you're not just tied to that one. You can just say, for example, show me the command for pwd print working directory of executable, or show me the command for calendar. So any command that you type in, it just will give you the output here. And then I also mentioned that I have other chapters. So chapter 3 is for intermediate. Chapter 4 is, this is chapter 2 for basic commands. And then we have chapter 3 for intermediate, which is this one. Unix and Linux intermediate. Similarly, you have all these 33 commands. You can practice them, and you don't need Linux or Unix. You just click on these video, watch them, and practice them online here, and read the manual pages, as well as everything is online. So chapter 4 is advanced level, which is 88 commands, and each of these rows I have a separate video for it. As you can see here, I have part 1 of 4, part 2 of 4, and part 3 of 4, part 8 of 4, 8 of 8. All of that one is there for chapter 4. So you can watch them and learn from them. Chapter 5 is Unix or Linux shell scripting, and I'm showing you shell scripting here, as well as the videos that are available. You're welcome to watch these videos as well as practice them there. And then later on, I'll show you some other interfaces that I have here that you can actually practice Linux. For example, let's say you click on here, cat F. Here, FArgs is showing, but at the same time, you can do like say, okay, if I want to say uname-a, I can get the output of uname-a here. Uname-a. I mistyped it. So you have to type it correctly, and then the output here. And if you say pwd, for example, run that command, it runs it. And then if you say ls-l, run that command, it runs it. All of the commands that you do. For example, if you decide to remove something from my file.star.txt or something, I'm going to just say you're not allowed to run that command. So the program is smart enough to detect some of it, but please make sure that I'm helping you. Don't try to just keep wasting your time to just see if there's a way that you can just delete files or hack it. So at this time, I'm going to go back to my webuniversity.com here. And as you can see, we were on chapter 5, and then I could just go on chapter 5 again by clicking here and then follow chapter 5 here, Unix, Linux, and then the next chapter was chapter 6. You can welcome to just learn Apache web server. So this is chapter 5, and then the next chapter is chapter 6. This is also, I have videos for how to build Apache web server or Linux and Solaris, and you're welcome to watch that one. And then chapter 7 is the manual pages that I was just telling you. For example, here it shows the system D. You can run any command here that you do. Like, for example, let's say I could say, give me the command for scanf, for C scanf. So you can get that information here. You can see it's section 3 in there. And if I just search for like a mount command, which is section 8, so whatever command I do, my program is smart enough to know what section it is, it's going to find it. But if I say -S3 printf statement, this is going to show the printf statement from C library, which is the include the standard IO and then printf statement. Similarly, if I just say printf statement without the -S3 for section, this is section 1, then automatically it gave me the Unix command for printf statement with section 1, and you notice that this is different from that other printf statement. So this is very useful information. You could get 6 or whatever 13,000 commands that are available. In addition, then I said that I have this other one under my web university. I said man_pages. This one is about 66,000 technical documentation that I have sorted in alphabetical for you, so you can just go learn it. And then some of these banners are from Google. I haven't made any money on them, but I like to just have these ones available for you. if it interests you and saves you some money, because some of the classes that they offer is giving you cheaper classes, you're welcome to just click on them and then just buy something, or just get the discount that you want. So here you can see the Mac OS X, Linux man pages, Solaris, Windows, and Windows PowerShell. So on all of them, I have all of this information. Because I don't have the platform, some of them I had to pre-generate these files and then have it available. So if, for example, you're looking for a Solaris, let's say I'm going to do ZFS for zettabyte file system. And then this is just going to give me the man page for a zettabyte file system. Because it's Solaris based, ZFS and is also a command, and zpool is another command. Control F, and let's say zpool. And then zpool is here. So any command is available there. Similarly for PowerShell, if you want to do run Windows PowerShell. For PowerShell, for example, you click on here. For Windows PowerShell, there's about 2,000 some commands here. They're all available for you. You could get it. So like, for example, get time zone, for example, is here. And then the nice thing about this one is give you examples that you can run on your system as well. Okay. So I'm going to stop here. I'm not going to go through each one of those examples one by one, because this video is going to get so long. But you're welcome to just come in online, register, subscribe, and watch all these 350 videos whenever you have time. If you don't like my videos, you're welcome to watch somebody else's video on YouTube, but you don't have to pay so expensive kind of tuitions at university if you cannot afford it. So this is all free, and don't waste the time when this is free. Try to take advantage of them, because sometimes these websites and other ones, when people find it good resources, they just maybe purchase the company or something, and then at that time different owners, they may not provide it for free. So I cannot guarantee that this will be forever free, but please make sure that you can just subscribe and watch it and enjoy it, and God bless you all. Have a good one. Take care. Bye-bye.